In the previous video, we saw how you could find the length of a string, how you could copy a string. Well, it turns out a lot of these functions are already provided in the string library that comes with most C compilers. So most C compilers will provide a library of string functions such as these. For example, convert a string to a long, string to an unsigned long, string to a float, string to double, string double, find the length of a string, copy a string. So we've set up a nice function that these very succinct or very terse loops to convert to make a copy of a string. Well, you don't have to do it. You don't have to use those functions. You can just use the library function strcpy, or the safer alternative to strcpy, which uses a limit. That is, it only copies up to a certain limit. That would prevent errors that would happen if you forgot, for example, your null termination character. So this is a little tiny bit harder to use in that you have to specify not only the source and the destination, but also the maximum limit for the number of characters you want to copy. But it's safer. So a string duplicate, the string compare, this is sort of like the string.compare function. String.compare method that we've used in Java. And there's also the safe version with a limit. strn stands for do a compare up to a maximum of n characters. And you specify the n as an extra parameter in strncmp. There's also string concatenate, take two strings, append one to the other. There's also version that's safer. String search, character-wise, substring-wise, so you can search for a substring inside a string, and a string tokenizer that takes, let's say, a big long string, converts it to tokens that are separated by white space or whatever. Actually, you can use any delimiter you want. Okay. Let's take a few of them and take a look at how they work. String length is probably one of the simpler ones. To use it, you have to pound include string.h. The way you use it, you pass in an argument, which is a pointer to car. It's treated as a constant, that is, it's not modified by strlen. So let's say you have a pointer to car s, assign it to whatever you want, and you just call strlen. It returns an int, something like an int. So whatever this is, you can use %d to print out the value that strlen returns, because almost always it's going to be compatible with an int. If you want to use strcpy or the safer alternative, which is strncpy, which has an extra parameter which says the maximum number of characters that you can copy before. So the reason you have this is because, let's say the source is missing the null termination character. Well, you might keep going, you might be stuck in an infinite loop. Well, not infinite, but it might be stuck in a loop for a long time, copying all kinds of things that you don't want to copy from src into destination just because you forgot to put in a null termination character or something like that. Well, here's how you'd avoid that problem. You'd say, well, only copy up to a limit. If you reach this limit, don't copy anymore because maybe there's a problem. The null termination character was missing. How do you use this? Make sure you have a source string. It can be an empty string or any number of characters, but make sure for the destination that you allocate enough memory to hold that entire string. So call strlen to find the length of the string, and then add 1 to it for null termination. Use malloc to allocate memory for that string, and then do the copy. So it's your responsibility to make sure that whatever pointer you pass in here for the destination actually does have enough memory that you've allocated from the heap, usually, so that you can copy everything from the source to the destination. So that's the programmer's responsibility, whoever's using it. You can duplicate a string similarly. So here strdup allocates the memory. So it's a little bit, it's convenient, but also it might be unsafe because who knows, if you forgot to put in null termination character, or if this S is really large, it's a really large string, well, you might end up having strdup allocate a whole lot of memory, maybe more than you intended. So it's definitely easier to use. Let's say you have a source string, assigned to whatever. You just call strdup, one argument, which is the source, assign it whatever it returns to the destination. strcmp, strncmp, both work in a similar way. The difference, of course, as with strcpy, is that strncmp has a limit, number of things that you will compare. So it has both of these take two strings as arguments, and they compare character by character if they are equal. If they are equal, as long as the first characters of each are the same, you can go on and move to the next character of each one. Check that. If it's the same, go on and move. As soon as you see a difference, it will return a value that's negative, meaning that S1 is somehow smaller than S2. 0 if they're exactly the same, or positive if S1 is bigger than S2. So in that the exact value, you might want to check the man page to see exactly what the difference is. Almost always this is used to just check for equality, to see if they're actually the same or not. Concatenate takes two strings, source and the destination, and appends the source string to the end of the destination string. Okay, so and it's your responsibility, you the programmer, to make sure that even though destination, let's say is hello, it would need at least 6 characters, that is 5 for the hello, plus a null termination string, plus it needs more memory to allocate, more memory to accommodate all of the characters that might be copied over from SRC to the end of destination. Okay, so you have a source, you have destination, 2 strings, concatenate the source to the end of the destination. D has to be large enough, and you, the programmer who calls this strcat function, you are responsible for making sure that D is large enough. If you happen to write over illegal areas of memory because D wasn't large enough, then your program could potentially crash. So there's a safe version of this. strncat has a limit to the number of things that it will copy. So this is useful because if you chances are you allocate memory for dest, you know how long it is, how much space there is beyond the null termination character. So you can find out the limit, the number of characters that you can copy over from the SRC, and pass that in as this final parameter in strncat. Okay, so you can search for a character inside a string. That's pretty straightforward. You pass the character in that you want to search for as an int. It's actually stored as the 4th or the least significant byte of an int. You typically don't have to worry about it. If you use character C, for example, is equal to k, you're going to search for the first location of the C, or first address of the C. First address where you find a K, the letter K, you put that into the C and pass in the C. That's fine. That'll work. Even though it expects an int, you can pass in a character. That's perfectly fine. C will do the type conversion and all that. So S is not going to be changed because you're going to just look inside S to find if that character C is in this array of characters, and so you're just going to check the values, you're going to read the values of S, you're not going to change them, so that's why this is a const. Okay. And you can also search for a substring inside a string. In that case, you have 2 character pointer pointers as parameters. So you're looking for needle in the haystack, and so the first string is this is the bigger string, usually the one that you're going to search in. This is what you're going to search for, so a substring. Of course, they both have to be null terminated. If they're not, well, you'll run into trouble. So let's say str is some big huge string, and you're going to search for a substring, the the. So this is how you use it. You put the thing that you're going to search in first, the thing that you're going to search for second, as parameters to strstr, string search, or substring string search. Okay, so we'll stop here for this video. That's the end of looking at a whole bunch of library functions in C. Let me just bring up that slide with the complete list. We didn't look at every single one of them. There's a lot that you can look at, but once you get used to a few of them, look at a few man pages. The rest are pretty straightforward. You can figure them out, I think. Just keep in mind null termination. You can use safe alternatives using the strn versions of some of these functions, not all of them. And once you figure out how to use a few of them, I think the rest will be fine.